Energy can be defined as the capacity to do work, and the mathematical formula for energy can be given as E is equal to integral P dt. That means if we integrate power over a particular interval of time, then we can obtain energy. And the units of energy are joules or watt seconds. And as we already know, the mathematical equation for energy is E is equal to integral P dt, and we can split this interval minus infinity to into two different intervals. One is from minus infinity to 0 and the other is from 0 to t. This is called the initial energy present in the component, and this is the energy which is consumed from the interval 0 to t. And now coming for the calculation of energy for all the three basic components, as power energy is nothing but the integration of power, we know that the formula of power for resistance is I square into R or V square by R. And if we consider the excitation to be a linear one, then we can simply replace this by I square R into T or V square by R into T. These are applicable only when it's a linear excitation system. And for inductance, the energy can be written as same integral of P dt, and the power can be written as V into I. Here the voltage V can be replaced by L di by dt into I of t dt, and if we do this integration part, it will give rise to half Li square joules. This is for inductor. And now coming to the capacitor, the same integral P dt, power can be written as the product of V into I, and this current part of the capacitor can be replaced by C dV by dt. So after integrating this, we will get it as half CV square joules. The basic definition of power is it is the rate of change of electrical energy or the rate of work done. Now the mathematical equation for power can be given as P is equal to dE by dt or dW by dt, and the units of power are joules per coulomb or watts. As we already know that P can be written as dW by dt, and we should multiply and divide it by dQ. If you multiply and divide it by dQ and rewrite the equation, we will get it as dW by dQ into dQ by dt. Now this part dW by dQ can be written as voltage V, and this part dQ by dt can be written as voltage and as a current I. Now the power P can be expressed as product of voltage into current. Now we'll write the equation for power for some basic elements. Now coming to the resistor, the equation of power is P is equal to V into I, and now the I can be replaced by V by R. We'll later study it in Ohm's law. So if we replace I by V by R, then you will get it as V square by R. Or we can also replace V with IR, and we'll get the equation as I square into R watts. Now for inductor, the power for inductor can be written as same, the product of V into I. And now we can replace V with L di by dt, because the VI relationship in inductor is V is equal to L di by dt. And now the power in inductor can be obtained as Li di by dt watts. And now coming to the capacitor. For capacitor, the power P can be written as the product of V into I, and we can replace the current I in the form of C dV by dt. So we'll get the equation as CV dV by dt watts.
Okay, namaste, bye bye.